the basic tissues. 4 basic tissue types occur, and these are woven together to form the fabric of all organs. The 4 basic tissues are epithelium, connective tissue, muscle tissue, and nervous tissue. A thorough understanding of each of these 4 tissues is necessary before beginning an examination of individual organs or systems. Epithelia consists of closely aggregated cells, separated by only minimal amounts of intervening intracellular substances. 2 general categories are recognized: a lining or covering type of epithelium, organized into sheets of cells that form barriers, and glandular epithelium, modified for secretion. The sheet form of epithelium covers the external body surface as the epidermis, lines the body cavities, pleural, pericardial, peritoneal, as well as the lumina of the cardiovascular, digestive, respiratory, and urogenital systems. All epithelia lie on a basement membrane and are avascular. Learning objectives for lining or covering epithelium. 1. Be able to locate, identify, and classify the various types of epithelia in a given section of histological material. And 2. Be able to identify the various apical specializations associated with specific epithelia and understand their functional connotations. If the covering or lining form of epithelium consists only of a single layer of cells, it is termed simple. If 2 or more layers of cells are present, of which the superficial-most cells do not reach the basement membrane, the epithelium is classified as stratified. Once this determination has been made, the next step is to determine the geometric shape of the superficial-most cells to complete the classification. Epithelial cells can be divided into 3 types according to their geometric shape. 1. Squamous, a thin, flat, plate-like cell. 2. Cuboidal, height and width of the cell are approximately equal, with the nucleus nearly touching all surfaces. And columnar, height of the cell is greater than its width. Thus, epithelium consisting of a single layer of cells can be classified as simple squamous, simple cuboidal, or simple columnar. The term mesothelium is a specific type of epithelium, simple squamous in type, that lines the pleural, pericardial, and peritoneal cavities. The term endothelium is a specific name given to the simple squamous epithelium that lines the cardiovascular and lymphavascular systems. To become familiar with the various types of epithelia, a number of different organs should be examined. Begin with sections from the gastrointestinal tract, as the lumen of this tube is lined throughout its extent by a simple columnar epithelium. The external surface is covered in most regions by a mesothelium. And compare these 2 epithelial layers. This is a section through the fundic stomach. This area here, as indicated by the pointer, would be the lumen of the gastrointestinal tube, and in this case, the lumen of the stomach. Even at this low standing magnification, one can observe that the epithelium lining the lumen of the gastric stomach consists of a simple columnar epithelium. So this is where the examination, or one of the surfaces that should be examined, as this region as indicated by the pointer. One should also examine its external surface, as indicated here by the pointer. It is this surface at the tip of the pointer that is going to be lined by a mesothelium, a form of simple squamous epithelium, And if one can look in this particular field, there's a small artery present here. Even at this scanning power, one can make out little dense nuclei. This would be the endothelial lining, another form of simple squamous epithelium specific for the cardiovascular system at this particular location. Now let's look at these at increased magnification. Once again, this is the external surface of the stomach. At the tip of the arrow, one can make out the flattened nuclei of it, the simple squamous type of epithelium, or mesothelium in this particular case. The cytoplasmic boundaries are quite indistinct at this magnification because of the very flat plate-like nature of the cells making up this epithelial barrier. Viewing it at increased magnification, this is a fairly decent section through the mesothelium. Remember, an epithelium is a covering or lining type of epithelium, so you want to look on the external surface of various organs and other structures. So this is the mesothelial lining, a form of simple squamous epithelium. The nucleus of one squamous cell is located here, the next one is located here, one is here, and one is here. This very thin interface extending to about here shows you the extent of its cytoplasm. So these are very flat plate-like cells. So I'm trying to draw with the tip of the arrow sort of the depth of this particular epithelium, and you can see the cytoplasmic sort of blurs between nuclei. Let's trace it by moving the microscope a little bit and get a slightly different field. To examine. And once again, you can see this very flattened plate-like cells. Here you can see the cytoplasm is lifted up and broken there a little bit, but here you get a pretty good idea of what these very flattened squame cells look like. In this case, it's mesothelium. Now, if we go into the interior of this particular tissue slightly, we can see a small blood vessel located here. This is another form of simple squamous epithelium, but it's given the specific name endothelium. And here it is. The nucleus of this cell located here, this one here, 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 and here. And so the entire lumen is lined by this simple squamous type of epithelium. The most obvious structures present are the nuclei of these endothelial cells and the cytoplasmic extent, this very thin, flattened profile of cytoplasm extending laterally from the nucleus. This is the larger vessel that we saw at increased or at that scanning magnification, a small artery, the structure here, but once again you can see it's lined by the nuclei of endothelial cells, and in this particular case this little light gray line is sort of the depth of the cytoplasm of these very flattened plate-like cells that you can see lining the lumen interior. Situation in the same field of view, if we go back to the more medium power objectives, where one can compare the two types of simple squamous epithelia, the mesothelium lining the external surface, and is actually the visceral layer of the peritoneum, and endothelium lining this small vessel here, which is a form of simple squamous epithelium as well as this larger vessel, in this case a small artery. Also in the field is a small capillary at the end of the pointer, lined by a single cell of endothelium. Having looked at the simple squamous forms of epithelia, that is mesothelium and endothelium, then proceed to the luminal surface of the stomach and examine this area for simple columnar epithelium. This is the epithelium that lining the lumen of the stomach. It consists of a simple columnar lining epithelium. I'll trace the nuclear profiles of this simple columnar epithelium with the pointer. So all these round purple structures are the nuclei. And because it is so folded, this particular tissue, once we get beyond the area that was indicated by the pointer, such as here, due to the folding of the tissue, it looks like a massive collection of nuclei. But this is simply a fold in the tissue, and you're cutting through the tops of the cells, like as indicated by the pointer here. A section would have gone through here, clipping the nuclei, and so you didn't get a perfect perpendicular cut through the length of the cell and making it somewhat confusing at initial observation. This is a typical simple columnar epithelium. And let's look at it at a little bit increase in magnification. Here's the layer we wish to examine. The pointer is going through the nuclear profiles of this simple columnar epithelium. The apex, or the top of the cell, is here. The base is here, resting on a very indistinct basement membrane. So the lateral boundaries of the cell extend from here to here. The top is going from here, the base here. And you can see they're bent a little bit. They all form a simple layer, a single layer of cells that are columnar in shape. That is, the height is much taller than the width of these cells. In this particular case, this light staining area here, non-stained area, is a collection of secretory granules, mucin granules, that are unstained. They're transparent and you're looking through them. Using different histological stains, one could stain these blue or red or black or whatever the desired color would be. So this is a classic example of a simple columnar epithelium. This is another section taken further down through the gastric lining epithelium. The simple columnar being located here, though it is not as pretty. The reason for looking at this section is to look at the apices of this columnar lining epithelium. These intense staining bodies, as indicated by the arrow, are called terminal bars. They unite the apices of the columnar epithelial cells tightly together. At an ultrastructural level, that is, looking at them with the electron microscope, these consist of the tripartite junctional complex. That is, a zonula occludens, a zonula adherens, and a desmosome or a macula adherens. Those three elements make up the light microscopic entity known as the terminal bar. Another feature that should be demonstrated to you is when you encounter a field such as this. If one can envision, these are the apices of several cells as if you were looking down on them from the superior level. If one envisions a section such as this, as indicated by the pointer, the cut coming through the tops of these cells, and then flipping it over and then looking at it, this is the type of honeycombed appearance or field one would obtain. So you've cut through here, flipped it up 90 degrees, and you're looking directly down or into the interior of the mucin granules within these cells. This is due to the folding and curvature of these tissues, and it's a problem that you'll simply have to deal with in developing a three-dimensional image in your own mind when you look at enough of these particular sections. This is a section of small intestine, specifically the jejunum. Once again, examine this particular organ or tissue for simple columnar epithelium. The arrow indicates the lumen of this small intestinal section. Examine this region or any of the surface for a simple columnar epithelium. This is a region of the luminal surface of the small intestine showing a simple columnar lining epithelium or an intestinal epithelium. The epithelial layer extends from here to here. Though a basement membrane isn't visible on this particular section, it should be residing or lying right about this location. These are the nuclei of this epithelial layer. So these cells are extraordinarily thin but yet tall columnar, the base of this cell being here, its nucleus, and then its apical extent all the way to the lumen. Because the small intestine is involved in tremendous absorptive capacity, it shows this fringe of little finger-like extensions of the cell membrane extending from the apical surface of these cells. This is the so-called microvillus border, or if you're using older text, the light microscopic term is often used. That is a striated border because it has little stripes, or so it appears. There's little indentations or stripes extending from the apices of these cells. Nonetheless, this striated border is representative of an intense microvillus border. Since it's here, this cell with mucin granules accumulating in its cytoplasm is a goblet cell. Its nucleus lies here. It has a little thin cytoplasmic process in touch with the basement membrane, and it will be discharging its mucin granules into the lumen over time. Now, if one moves away from this area, you can see due to the folding, the region becomes quite confused, and that is because of the folding in the irregular contour of this intestinal epithelium. So one will have to look for a vertical straight cut through the surface, the surface villi, these finger-like extensions, to look for a simple columnar epithelium. If you move the field along, one will eventually encounter such an area. I moved a little bit further along. Here we can see the epithelium, the extent of it, beginning in the lumen where the tip of the arrow is. This would be the base of the epithelium here. Here are the nuclear profiles of all the cells comprising this particular layer. If one looks very, very carefully, you can just barely make out a little light indentation, so you can see the lateral boundaries of these cells as they're closely packed together. So this cell with its microvillus border would extend to this nuclear profile, and then its base would be resting on the basement membrane at this location. So this is a simple columnar lining epithelium lining the entire intestinal tract. This type of an epithelium will be found throughout its extent, both the large and small bowel. It will be characterized by goblet cells, and typically because of it, to increase its absorptive capacity, this intense microvillus border, oftentimes referred to as the striated border. This is a section of the oviduct. Once again, the lining epithelium would be located within the luminal surface, and we'll see that once again it is a form of simple columnar lining epithelium. Examine this at increased magnification. This is the simple columnar lining epithelium lining the oviduct. The epithelial surface extends, the apex is located about the region of the arrow, and it extends to where the arrow indicates here, near the basement membrane. So this is a simple columnar epithelium, the nuclear profiles residing as indicated by the arrow. Now in this particular case, in this type of a unique type of epithelium, unique in the sense that it has extending from its apical surface cilia. Cilia, little apical modifications, projections that are motile and aid in moving the ovum down the oviduct. If one looks very carefully and using the fine focus on your own microscopes, focus up and down, individual cilia can be seen extending from the apices of these particular cells. There may be 300 to 400 of these motile projections projecting from an individual cell. Note that in this particular case, there's a little dark, intense beaded line running along the apical surface of the cell just beneath the ciliary structures. These are the basal bodies, little centriole type of structures that are instrumental in generating the axioneme, or the microtubules that fill the center of each individual microvillus and provide that apical appendage with mobility so it can beat. Also within this lining epithelium are simple columnar cells modified for secretion that do not show cilia or the basal bodies. One is located here, and you can see how the cytoplasm has extended or ballooned out into the lumen of the oviduct. So its apical extent would be here, the nucleus located here, and its base would be on the basement, resting on the basement membrane at this location. When this type of a situation is encountered, where you have cilia, you put that as a prefix on the name or the classification scheme of the epithelium being considered. So in this case, it would be a ciliated, simple columnar epithelium. Another tissue in which to examine the simple form of epithelia, where one can compare simple squamous, simple cuboidal, and simple columnar, is going to a region of the kidney. The kidney consists of epithelial tubules known as nephrons. If one goes to the medulla of the kidney, as is shown in this particular field, and one can tell this region from the cortical regions in that all the tubules in the medulla run in parallel to one another rather than meandering around and not really organized in any one direction, as is true of the cortex. One can compare the three types of simple epithelia. Do that at increased magnification. This is a region from the medulla of the kidney, showing you a comparison side by side of these epithelial tubes, and different regions of these epithelial tubes will be lined by a different form of epithelium. Note that some tubules are lined by a simple squamous epithelium, as indicated by the pointer. This particular tubule, this tubule shown here, this one here, this one over here, this one here, so on and so forth. Immediately adjacent to them, those tubules lined by simple squamous epithelium, you'll see tubules that are slightly darker or more granular in color. The nucleus is more or less centrally located, and you have an equidistant amount of cytoplasm both above and below it. So these are fairly close to what a simple cuboidal type of epithelium would look like, also lining this particular tubule, this tubule as well, this one here as well. In the same field, one gets an opportunity to compare it with another tubule. In this particular case, you can see that the height is much greater than the width, and so these would be an example of simple columnar type of epithelial cells. Move around within the medulla and identify several tubules lined by these various types of epithelia. This larger tubule, as I move the field just slightly, perhaps gives a better comparison or a better profile of what a true simple columnar looks like. You can see the height is much greater than the width, and the nucleus usually occupies a more basal position. Compare it with a tubule such as this. It's much flatter or lower, more cube-like, so it's simple cuboidal, and then the simple squamous tubules at this particular location. The very same tubules seen at increased magnification, lined by simple squamous, simple cuboidal, and if we move the field upward, one that's more inclined to be called or classified as simple columnar. Occasionally you'll run into a situation, perhaps more often than not, where it's difficult to make a real accurate determination. And some authors and people will use the term low columnar to indicate that type of a cell. But for our practical purposes, this tubule is going to be lined by a simple columnar epithelium. These tubules that are pretty close to being cubes, the epithelium that is, simple cuboidal, and then finally a very flattened form, such as indicated by the arrow, simple squamous. This is a section of trachea. This particular material you'll come to know a little bit later in your experience as hyaline cartilage. But look at the luminal lining, the interior of this tracheal tube for another form of epithelia. What are the simple forms of epithelia that we have yet to discuss? This simple form of epithelium is referred to as pseudostratified columnar epithelium. This is what pseudostratified columnar epithelium looks like. This is lining the trachea. Note that even though it is a simple columnar epithelium, it's a rather confusing one. You have a layer of nuclei running here, another layer appears to be here, and another one right above the basement membrane, which in this particular section can be visualized. This sort of light salmon area here is a thickened basement membrane. This type of an epithelium, this pseudostratified columnar epithelium lining the respiratory tree, is indeed simple. That, by definition, all of its cells, all of its cellular components touch this basement membrane. However, not all of the cells reach the apical lumen, and the reason for this is that it's comprised of a heterogeneous type of epithelium. That is, several different cell types make up this particular epithelial lining, all of which touch the basement membrane. Therefore, it is indeed a simple form of epithelium, but because it was confusing to the initial investigators who developed the classification scheme, before it was separated and sort of dissected apart, they assumed that this was a stratified form of epithelium. Then, having discovered that indeed all these cells did or reside on the basement membrane, send a process down that touches it, they changed the classification scheme to be pseudostratified columnar. In other words, a falsely stratified columnar epithelium. Even at this magnification, one can make out cells that look a little bit different, lighter, with a flocculent type of material within their cytoplasm. These are goblet cells, also found within the trachea. We had looked at one earlier lining the intestinal tract. Examine this particular epithelium at increased magnification. Typical pseudostratified columnar epithelium lining the trachea. The reason this epithelium looks a little bit worse for wear is because this is a typical paraffin section rather than some of the crisp plastic sections that are used used elsewhere and observed other tissues elsewhere. So it looks a little bit thick and is muddy in nature. If we look along its surface, you can see melded together, sort of clumped together, these little projections here are cilia. And cilia are typically found within the respiratory tree, obviously for functional reasons. Also, one can make out the little mucin granules of goblet cells, and one can more easily see the three layers of cells, sort of a columnar epithelial profile here, if one compares it to the profile of the nucleus. A little rounded group of cell nuclei here, and another cell layer here, these so-called basal cells. Nonetheless, all these cells reside on the basement membrane located here, so it satisfies the definition of being a simple columnar epithelium. So it's given the name pseudostratified columnar. Because cilia are present on some of these cells along its surface, the complete classification scheme for this type of epithelium is ciliated pseudostratified columnar epithelium with goblet cells. A little bit later on, we'll simply refer to this epithelium as a typical respiratory epithelial type. This is another section of trachea to illustrate the ciliated pseudostratified columnar epithelium, but with a plastic section, so the resolution is much crisper and the preservation looks much nicer. So this is the epithelial surface extending from where the tip of the arrow indicates to that little thin basement membrane that's being traced by the tip of the pointer. One can easily make out the so-called basal cell layer, sort of an intermediate layer of nuclei, again being traced by the pointer, and then some that occupy that upper or third layer. So this is how it appears when in a much better preparation, where the section is much thinner. All the details look much crisper. And this phenomenon is true of most tissues when you compare both a plastic embedded and a paraffin embedded type of a section. Increasing the magnification slightly and moving along, if we look at the apical area of this particular epithelium, once again, with this type of a preparation, you can begin to make out the basal bodies. And if one looks very carefully along the apical surface, you can see that little fringe of individual cilia that are going to reside on the apices of most of these particular cells. So this is a typical respiratory type of epithelium, which would be classified as a ciliated pseudostratified columnar epithelium with goblet cells. This is a section of the epididymis, a portion of the male reproductive tract, its excurrent ductal system. Examine it for another form of pseudostratified columnar epithelium. Examine some of these tubular profiles where the epithelial lining will be found at increased magnification. This represents a lengthwise cut through one of these tubular profiles. The base, move this down. The base of the epithelium is indicated by the tip of the pointer. The apical region would be, again, indicated by the tip of the pointer. It, once again, consists of two cell types. The cell type known as the principal cell and basal cells make up the second. The nuclear profiles are here, so you can see it as a fairly tall columnar epithelium. At least that principal cell is, extending from about where the tip of the pointer indicates to where approximately at this location. Also located within this epithelial layer are little round cells that hug the basement membrane. These little called basal cells or little germinal type cells that are replacement cells. Nonetheless, both touch the basement membrane. It sort of has a false indication of stratification, so this is a pseudostratified columnar epithelium as well, though it appears a little bit differently. And we'll see later on that most of the male excurrent ductal system is lined by this type of a pseudostratified columnar epithelium. Another feature that's illustrated here is a rather sophisticated form of microvillus. These are oftentimes clumped together and form these wisps coming out from the apices of the cells. These are the so-called stereocilia. A highly branched form of microvillus, not true cilia, they do not beat, but are increased surface area once again for absorptive capacity, but have been given the name stereocilia. Look at these structures at increased magnification. This is a section through that same region of pseudostratified columnar epithelium, showing the nuclear profiles of the basal cells, the nuclear profiles of the principal cells, which are the tall columnar form that extend from the basement membrane all the way to the top. You can see they're very tall cells. And look very carefully in this particular section, one can make out numerous tight junctions, or these terminal bars, these intense little lines at the apical surface. So that gives you the width of the apices of some of these cells, which you can see are quite narrow. So the distance between two of these terminal bars is the apical extent of a cell. Here you can see this wisp of material coming out. These are these so-called stereocilia. Actually, this wisp is an amalgamation. Several of these highly branched microvilli sort of fused or clumped together, giving you this wisp-like indication or profile, morphological feature. The Golgi complex of some of these epididymal cells are extraordinary, and this is why you have this vacuolated large appearance in these particular cells in their supranuclear and apical region. These are huge complexes made up of this Golgi complex and apparatus in this particular epithelium. Stratified types of epithelium. Despite the large number of cells with different shapes, recall the classification scheme remains based on two questions. One, are two or more layers present, the outermost of which is not in contact with the basement membrane? And two, what is the geometric shape of the superficial-most cell? Stratified squamous is by far the most common of the stratified epithelia. Begin your examination of stratified epithelia by looking at a section through the esophagus. Once again, determine the esophageal lumen, which is shown here at the pointer. And if we course through the wall of this particular tubular structure, you can see various other tissues being present that we need not concern ourselves with now, this being the external surface. Retreat to the lumen, or the lining interior of this particular structure. This huge epithelial tissue here is an example of non-keratinized stratified squamous epithelium, oftentimes referred to as a wet form of stratified squamous epithelium. The epithelium extends from where the tip of the pointer indicates to this area here, which is roughly the position of the basement membrane as seen with the scanning objective. So the epithelium in this particular case is fairly thick, extending from the lumen, where the arrow indicates, all the way to here. So you can see it's made up of a series of a number of layers of cells. Examine this type of epithelium at increased magnification. We are looking at this stratified squamous type of epithelium with an intermediate objective. Here we can see a layer of basal cells lying on a real thin little basement membrane. We can see that these cells, as they progress and migrate towards the interior, which indeed they do, they begin to change their shape. They become more spindle-like or fusiform, and as they approach the luminal surface, become flatter and flatter. So we've gone from columnar to sort of a diamond shape to more of a flattened type of epithelium that will eventually be sloughed off into the lumen. Though you don't realize it in this particular section, these are flattened squames, but you're looking at them from the flat surface down as if you were looking at a dinner plate. If you were able to turn this dinner plate over, you'd have a very thin, flattened profile, similar to what you saw in endothelial or mesothelial lining. I moved the section so one could actually see this where they're cut more vertically. Going from a spindle type of a cell here to a very thin, flattened, squame-like cell. You know the nuclear profile is missing. You can see these very flattened cells sloughing off from the lumen. So this is the epithelial lining of the esophagus, a wet or non-keratinized stratified squamous type of epithelium. When you run into a situation such as this, it's confusing. Go back to your initial classification scheme. Go back to the rules. Are there more than one cell layer present? Yes. It has to be stratified. Without worrying about the geometric shape of any other cell than the superficial most one, which is squame, that satisfies the definition. You're dealing with a stratified squamous type of epithelium. This is a section of thin skin taken off the back or the thigh region. The surface is the epidermis, as shown here, which is a type of epithelium, and that type of epithelium is a stratified squamous epithelial type. Now examine this particular epithelium at increased magnification, noting that it's a little bit thinner than that lining the esophagus. This is typical thin skin seen at increased magnification. Once again, the epidermis is made up of a keratinized stratified squamous type of epithelium. The epithelium extends from about where the tip of the arrow is to the basement membrane, shown at about this location. Once again, remember the classification scheme. Multiple layers of cells, so it is stratified. These cells change shape, and once they approach the surface become flat and plate-like, and therefore it satisfies the definition of a stratified squamous type of epithelium. In this particular case, the epidermis, these cells undergo a metamorphosis or a transformation and become keratin, a proteinaceous material that covers the surface of the epidermis. When this condition arises, this prefix of keratin is placed on the classification scheme. Therefore, this type of epithelium is referred to as a keratinized stratified squamous epithelium, as opposed to that lining the esophagus or the vaginal area, which is a wet or a non-keratinized stratified squamous epithelium. Examine a section of skin at increased magnification. A typical section at increased magnification through thin skin. Once again, a very thick type of epithelium consists of several layers of cells, therefore satisfying the definition of being stratified. These cells change their shape, which one needs not worry about at the present time, become a very flattened squame-like cell. You can see here by the nuclear profile and a little bit of cytoplasm that is extending out, and then will become the keratin. Stratified squamous, because of the keratin present, you put that on as a prefix, so it's a keratinized stratified squamous epithelium. It's this type of a stratified epithelia, by volume at any rate, is the most common form of the stratified epithelia. This is a section through thick skin that was taken from either the palms of the hands or the soles of the feet. It is another form of keratinized stratified squamous epithelium. This huge mass of structureless material, as indicated by the pointer, is keratin. If one envisions the palm of their hand and a development of a callus on the dorsal surface of the palm, this is that thick keratin type of material forming that type of a callus. So this is all keratin. The remainder of the epithelium begins about where the tip of the pointer is and extends from this location down to where the basement membrane would be located. So examine a section of thick skin briefly and compare it to that of the thin skin. Look at this particular section at increased magnification. The base of thick skin looked at increased magnification. Once again, this is where the epithelium begins. So it's lying on a basement membrane, though it's not completely visualized. One doesn't worry about all of these cells at the present time. You can see that it's made up of several cells of different sizes and shapes, some of which have granules, but that's not important at the present time. We know it's a stratified type of epithelium. These cells then flatten out to become the keratin. Therefore, it satisfies the definition of a keratinized stratified squamous epithelium, though it looks considerably different than the thin skin over most of the body. Another form of the stratified epithelia is transitional epithelium. This type of epithelium is restricted in distribution to the urinary system. The section in the field is through a ureter, that small tube that conducts urine from the kidney to the urinary bladder. Examine its luminal surface or interior for this typical transitional epithelium. This field represents a section typically of transitional epithelium in the non-distended condition. If one courses along its surface, it is obvious that it is stratified. Looking more carefully at its surface, you can see that it has sort of a scalloped interior luminal surface. Some of these cells, called dome cells, actually extend out and sort of balloon out into the surface or into the luminal region, as one can see here. This is fairly typical of transitional epithelium. If one courses along looking at this scalloped interior and these large balloon type cells extending to the surface, oftentimes one will encounter cells that are binucleate. That is, an individual cell will contain two nuclei. This is typical transitional epithelium seen at increased magnification, showing these large dome-shaped cells. This one particular cell here happens to be binucleate, having two nuclei residing within its cytoplasm. And the epithelial surface, once again, is fairly thick, extending from the luminal surface, as indicated by the arrow, to this region here, which is approximately where the basement membrane would be located. If one courses along, you can see these dome-shaped cells a little bit better at increased magnification, and how they bulge out into the lumen and give a sort of a scalloped interior to this luminal surface. So this is transitional type of epithelium, so named because it can accommodate to the volume or fluid placed or the pressures placed on this particular epithelium. If one thinks about the filling and voiding of the urinary bladder, this epithelium, as the organ stretches, can thin out and stretch and accommodate those forces without tearing. So it transitions from one functional condition to another. This is why it is referred to as transitional epithelium. Some of the more recent textbooks have once again changed its name, and perhaps appropriately so, in referring to it as a uroepithelium, indicating that it is this type of epithelium that lines the urinary system, and this is the only location where this particular epithelium is found. So this is transitional epithelium from the ureter. The other two forms of stratified epithelia, we have considered stratified squamous, are stratified columnar and stratified cuboidal. These are relatively rare epithelia and are found in transition points within the ductal system, primarily of large glands, such as the salivary glands. The tissue section on the field of view is a submandibular gland, and a large tubular structure, as indicated by the pointer, happens to be a large excretory duct draining this gland. This is one of the locations where one can observe stratified columnar and stratified cuboidal type of epithelium. This particular tube is being lined by a stratified columnar epithelium. Let's examine it at increased magnification. This is a section through the duct of the submandibular gland, one of its major excretory ducts, showing you a typical stratified columnar lining epithelium. Remember the classification scheme. Are two or more layers of cells present, the outermost ones of which do not contact the basement membrane? The answer is yes. What is the geometric shape of the superficial most cell? You can see that indeed it is columnar, therefore it satisfies the definition of this epithelial lining being stratified columnar. Examine it at slightly increased magnification. Again, increased magnification illustrating a stratified columnar lining epithelium. The superficial most cells, columnar in nature, a layer of basal cells which are a little bit more rounded. So we know there's two layers of cells present. The superficial most one of them is columnar, so this is classified as a stratified columnar type of epithelium. Having found and examined an example of stratified columnar, return to the section of thin skin in an attempt to identify a sweat gland, an eccrine sweat gland, one of the locations where one can observe stratified cuboidal type of epithelium. Leaving the epithelial surface and going down into the interior of the tissue, look for simple tubular glands. One is illustrated here. This is a typical eccrine sweat gland. It's classified as a simple coiled tubular gland. It consists of a single tube that goes down and then coils upon itself, much like a snail shell. This is a section through one of those snail shells, which in actual fact is this simple coiled tubular gland. Examine the ductal system, which is shown here, and we have two little isolated profiles of an adjacent duct at this location. This is an example of those two profiles seen at lower magnification. This little circular object is the duct through a sweat gland. The lumen is shown at the tip of the pointer, is that light or clear staining area. Note that once again you have two layers of cells. One layer of cells located or indicated by the tip of the arrow, the other layer of cells now indicated by the tip of the arrow. So there are two layers of cells, the luminal most or the superficial most of which is cuboidal in shape, therefore it satisfies the definition of a stratified cuboidal type of epithelium. Another profile through this same duct is shown at the tip of the pointer. So this is classic examples of stratified stratified cuboidal epithelium, It's relatively rare, and one of the classic places to observe it is in the ductal system of the eccrine sweat glands. This is the sweat gland here, shown at increased magnification. We just have a nick through our tangential section through the ductal system, and once again you can see even at up this high it is still lined by a typical stratified cuboidal type of epithelium.